So today we will be working on the second episode of our Golang Basics playlist. And in this episode, we will be learning about arrays, slices, for loops, the range keyword, and then, if time permits, a little bit of structs and methods. So let's jump right into it. Okay, so we again open our Golang Basics folder. Just clear the previous code. All right. So let's see what arrays are. So arrays are pretty much similar to what we have in JavaScript, what we have in C++, what we have in Java, basically every other language. So arrays are basically contiguous block of memory of a certain type. And once you have declared an array, you cannot change its size. So it is fixed in size. So it's not very useful in most real life situations unless you already know the size that you want to initialize it to. So array is basically a fixed block of contiguous memory. So let's see how to declare arrays in Golang. So as we learned in a previous video, we need to use the var keyword to declare any variable. So let's use var, let's call it array. And now, just like in many other languages, you need to use square brackets to declare an array. So we use square brackets and then we declare the type of the array. So in this case, I want an array of integers. And then one more thing, we need to mention the size of this array, how many elements this array can hold. So inside the square brackets, let's say we want number 5. So this is an array of 5 units of integers. So this is how you declare an array. Now this array is empty currently. It has basically automatically initialized to 0. All the values are initialized to 0. So let's try to put some values in this array. And how are we going to do that? So one way is this. We call the array, we try to access the index, in this case 0. Let's give it a value of 1. So this is one way of giving it a value. Let's do some more. 2, 3, 4, 5. This is 2, this is 3, this is 4, this is 5. This is index 4, index 3, index 2, index 1. Okay. So this is one way to initialize the indices of the array, but this is very, very tedious because again, we are manually writing every index and then initializing a value. So we don't want to do that. So let's just comment this out. We will be using a for loop. So first of all, how do loops work in Golang? So basically, Golang only has one loop. So if you're coming from JavaScript or if you're coming from C++ or even Java background, you know that these languages have for loop, while loop, right? Multiple versions of loops. But in Golang, there is only one loop, which is called the for loop. The for loop itself can be used as a while loop, as an infinite loop, as a regular for loop, right? Because Golang makes it so versatile that we do not need multiple types of loops. Just one for loop is enough for every situation. So in this case, let's use a for loop and iterate from 0 to 5 and then fill in the value inside this array. So we use for, now we declare an I colon equal to, like we did from our previous video, to initialize a variable. I is less than 5, I plus plus. Now, we are basically initializing a variable I and then iterating from 0 to 5, just like in every other language, nothing too fancy. Now what we will do, array of ith index should be equal to I plus 1. So we are filling each index with its one value incremented. So 0th index will become 1. So why is it throwing an error? Okay, unused. Okay, fine, no issues. And then let's just do this for now. And now once we have entered the value in the array, now we need to print these values to check whether the array actually has the values or not. So how do we arrange, or how do we iterate over this array? So to iterate over any object, in this case this array, we use the range keyword. So Golang comes with a range keyword which automatically iterates, which works on iterables in Golang. What are iterables? Iterables are objects which return an iterable value which can be used with the range keyword. What are iterables? We'll see more in detail in our Golang advanced classes after this basics is finished. But for now, just remember that arrays are iterables, maps are iterables. In certain cases, some of our own defined structs can also be iterable. Our own custom types can also be iterable. So iterable is any object which works with a range keyword. Just remember for now. Now, when we are using range keyword with array, the range keyword returns two values. The first value is the index, the current index we are ranging over, and the second is the value at that current index, right? So let's see. Range, we use the range keyword using range keyword, and then we use the name of the variable we are trying to range over. So in this case, array. Now, as I mentioned, the range keyword returns two values. So how do we use those values? Colon equal to, and then the two values, the first is index, and the second is the value itself at that index. So this is how you use the range keyword with an array. Now, one more thing. You must have noticed that the for loop in Golang does not have parentheses. If you try to add, it will start throwing an error. So Golang is very simplistic in nature, so we do not need parentheses to be working with loops. So just let's remove it. Okay. So let's come back to range with the array. So the range keyword, when we are ranging over an array, will return us the index and the value. So let's try to print these two and see what happens. fmt.printf, because we will be using some formatted strings just for fun. So let's see. Value at index %d is %d. If you don't understand what this %d means and what the string formatting is, please watch the previous video. I've explained this in detail in the previous video. So we will pass in the index, and the second is we will pass in the value. All right, so let's try to run this code. Go run main.go. Okay, so one more thing, printf does not automatically add new line at the end of the string, so we have to manually add the new line. So after %d, we will use an escape sequence for new line, which is \n. So what are escape sequences? They are nothing but string representation of certain characters on the keyboard. That's it. You can Google more about escape sequences if you want. Nothing too fancy. So now if you run it again, now you can see value at index 0 is 1, value at index 1 is 2, index 2 is 3, 3 is 4, 4 is 5. So our array has been filled up properly. So now this was the basic example of how arrays work in Golang. So let's see now how slices work and what exactly are slices to begin with. So let's just comment this all of this code out. Let's comment this one out as well. All right. So basically a slice in Golang is a dynamic array which can increase its length depending on how many elements you have fed into it. So a slice is basically a fancy term of saying vectors in C++ or array list in Java. It is the same concept, nothing too fancy. Basically an array that can grow in size as per the demand. That's it. That's the simple definition. Now let's see how to initialize a slice, or rather how to declare a slice in Golang. So again, we use the var keyword. Let's call it slice, and then now we need to integrate the type. So again, we use square brackets and then int. Now in this case, we will not mention any value inside the square brackets. So as you can see here, we mentioned 5 in the square brackets, which made it an array of length 5. If we do not mention any value in the square brackets, that means this becomes a slice now. It has 0 length, but it can grow in size. It does not have a fixed length anymore. So we are basically creating a variable, and we're telling the compiler that this is a slice which can grow in size in the future. So we are not giving you any particular fixed size. That's it. Now, this is one way, but this is basically a declaration. This is not initialization. So let's say if you want to create an empty slice, how do you initialize an empty slice? So instead of using the var keyword, we are going to use the colon equal to operator. So let's call it slice colon equal to, because we know colon equal to is used for initializations, right? Okay, so when you want to initialize any object, any inbuilt object in Golang, so also remember I'm saying object again and again, even though Golang does not have objects. So just for simplicity's sake, we just call it an object for now. So whenever you are trying to initialize any inbuilt type, in this case a slice or a map in Golang, you always use the make keyword. So the make keyword is similar to new in C++ or new in JavaScript or new in Java as well. So it basically allocates memory for your object so that you can start working with a particular object. So make is just like new keyword in other programming language, nothing fancy, just allocates memory for that particular object. So let's see, let's call make. So the make will take the first argument as a type of the variable that you're trying to initialize. So in this case, the type is square brackets int, which is the type of a slice. So square brackets int. Okay, and then when you're initializing a slice, the second argument it takes is the length of the slice. So in this case, we want the length to be 0. We do not want any elements in the slice right now. So we'll just give it a length of 0. So all errors are gone. Okay, now there is one more concept in slices. It is called the capacity. Now, what is the capacity? Capacity is basically, so a slice, how it internally works is it has 3 elements or 3 entities internally. The first is a pointer to the, so internally slice is also using an array. So the first internal entity that the slice has is a pointer to the array, underlying array. The second is the size, the length, the current length of the slice. And the third is the capacity, something called as capacity of the slice. So what is the capacity? Capacity is basically the minimum number of elements that the slice can hold before the slice needs to grow again. So let's say we give it a capacity 10. That means this slice can store 10 integers in it before it needs to grow. So capacity is not for our use, it is just for optimization, internal optimizations. So if you have a big capacity, the slice will not need to grow. You do not need to allocate more memory for growing the slice before the capacity fills up. So in this case, if you want to give the slice, you generally don't need to mention the capacity. The compiler will handle it internally and on its own. But let's say if you manually want to give this slice a capacity, you can do that in the make function itself. The third argument when you are trying to initialize a slice is the capacity argument. So let me give this a capacity of 10. So now the slice has a length 0, the size 0, the size is still 0, there are no elements in the slice, but it has still allocated a block of 10 integers in the memory so that we can put 10 integers without having to grow the slice, right? That is the entire concept. So I hope it makes sense, nothing too difficult, not too fancy. Okay, so now we have a slice of length 0, size 0, but capacity 10. Okay, now let's fill in this slice. Let's add elements to this slice. How do you add elements? So in the case of an array, we can directly use the indices because the array has a fixed size of 5. So it is already blocking 5 units of memory. But this slice is empty, right? Because it has a size of 0. So whenever you have a 0 size slice, you always need, and you want to add some values to it, you need to use the append keyword. So the append keyword basically takes the first argument as the object that you're trying to append to, and the second argument is the value itself that you're trying to append to the object. So in this case, the append function will take the slice as the first argument, and then the second argument will be the value, which is, let's say, 1, 2, 3, 4, 5 that you're trying to append into the slice, and then it will return the reference to the slice. So let's see how to do append. So we'll use slice equal to append. And you can see the compiler has already added the slice inside the append function. And then we want to add 1 to the slice. So let's just call 1. So this method, this append function will add 1 to the slice. That's it. Nothing too fancy. All right. Okay. So let's append 5 values. Let's see. 2, 3, 4, 5. Let's call it 5. All right, so we have appended 5 values to the slice. Okay, one more thing that you can see, if I just remove all these appends, one more thing you can see, the append, if you see the function signature of append, you can see the first argument is the type itself, and the second argument is a dot type. So there are 3 dots and then the type. So this 3 dot means variadic. So in Golang, we call these 3 dots variadic. Okay. So 3 dots of type like variadic integers. It just means that this function can take multiple values. That's it, right? Whenever you see three dots, that means that this function can take multiple values, not just one. So if you want to append 1, 2, 3, 4, 5 in one single line, instead of having to call it 5 times, you can do it like this as well. 5. This single line will append 1, 2, 3, 4, 5 in sequence into this slice. Now let's see whether this has actually worked or not. So again, we'll use our for loop with the range keyword to print whatever is in there in the slice. Okay, so the first will be index, second will be value, range and slice, and then we need to print fmt.printf. Let's just pick this. All right, so let's print it now. Let's see how it works. Okay, see, you can see it is working again. So this is the basic concept of slices. So I hope this makes some sense. I hope it's not too difficult to understand. Okay. And if you have any more questions about the slices, about arrays, you can put them in the comments, or you can message me on Instagram. My link will be in the DMs, or in the description, sorry. Okay, so we are done with slices, we are done with arrays now, and we are done with for loops as well. So we understand how for loops are working. We understand how range keyword works. All right. Now, what else is left? Yeah, so I said we will be learning a little bit about structs and methods. So let's see. Let's see. Let me comment this out. Let me comment this one out as well. All right. Yep, structs, methods, and interface. Okay. So let's just clear all this code. Now, so far we have seen inbuilt types in Golang. So arrays, slices, ints, floats, booleans, strings. So all these types are inbuilt types in Golang. But let's see if you want to create your own type. Like if you have a custom object or a custom type that represents a certain object for your business logic. So how do we do that? So let's say I'm trying to create a function. I have a business requirement where I need to. So my basic entity or basic unit of data is basically a complex object which has certain key fields in it. So I'm trying, let's say I'm trying to create a social media service, and the social media service needs a table of users, right? And the users can have a name, can have an age, can have an email address, can have a password, so things like that. So if I want to store a user in the database, or I want to do some manipulation or some data manipulation on this user, how can I store this user as a single entity? If I store name, age, like if I store name as an integer, and if I store name as a string, name as a string, age as an integer, for one person, how will I keep all this data together in one place as a single entity, so that I can work on it? So since Golang does not have the concept of objects or classes, but Golang has something called as structs. Structs is similar to what we have in C, base C language. Struct is basically, you can understand it as an object in JavaScript, simple. So it has curly braces, it has key value pairs, and you can use it as a single entity to represent a complex object or a complex data. So let's see how structs work. Let's create one struct. So if I want to create a social media app, I need some sort of data unit to store the data of one user. So we will be using structs called user struct, and this user struct will have name, age, email address, and password as the fields, so that we can store this data of users in our application. So to create a struct, we use the type keyword, type, type. Then we need to give the name of the struct. So let's say in this case user, and then we use a struct keyword, struct, and then curly braces. That's it. Even empty structs are valid. This works. If you just save it now, this will be absolutely valid code. But since our user contains certain data, we need to add this in a struct. So the first data that contains is name. So let's say name would be a string. and then age would be an integer, and then there's an email, again a string, and then there's a password, which is again a string. So this is how you create a struct. Now what does a struct mean? Struct just basically means it is a representation of a data, and it is a new type. So now you can declare variables of type user. So struct has basically created a new type for you. So let's see how this works. If I create a variable, let's say user1, and then now I can use the user struct as a type for this user1 variable, and I just save it. Now this is a absolutely valid code. You can see the compiler is also showing you the type is type user. So structs are basically creating new types for you, right? And this user1 is basically an instance of this type of user, or let's say an object. The Golang does not have objects, but this can be, let's for simplicity's sake, let's say this is user1 is an object of type user. Now if I want to initialize, or let's say put in values inside the fields, all I need to do is use user1 dot name. Just like in JavaScript objects, you access the key value using the dot operator. Again, you can use the same concept here. Let's call it abcd. Then again, user1 dot age, let's call it 10. User1 dot email, let's call it abcd at the rate gmail.com. And then user1 password, let's call it abcd12345. So this is one of the ways you can basically initialize the instances of instance of your struct. Now why do we need these structs? Like I mean, of course they encapsulate related data together, that is the first point, but is there any other benefit other than this? Yes. So there is one more benefit or one more need as to why we need structs in our code. So we know that we know that Golang has functions, right? So let's create a function, and let's call it custom print function, which basically prints, and it takes a, let's say it takes a string value, and it just prints the string value. Okay, so this is basically a normal function in Golang. That's how we define functions in Golang. But let's say you want to create functions that that cannot be called like from anywhere. So this is custom print. If I want to call this in the main function, I can easily call it directly, and then give it a string hello. So the custom print function can be directly called in our main thread. But let's say we want functions which are linked to a particular instance of struct. They cannot be called outside of it. So what do I mean by that? So let's say that in this user struct, we want a function that specifically prints the name of the user struct. So if let's say right now I need to print the name of the user struct, I have to physically manually pass in the name inside the custom print function, right? So I am basically adding it as a parameter, and then this custom print function is printing the name. But I do not want to use a general purpose function. I want to use a specific function which only works with my struct. So these kind of functions are called methods. Methods are basically functions which are linked to a particular struct. That's it. In simple terms, methods are functions which are callable or which are linked to a particular instance of a struct. So I hope this makes some sense, but let's see what I mean by this. So if I remove this custom print, we don't need it for now. Let me just comment it out. All right, so this custom print is a normal function. Now we need to declare a method. A method is basically a special function which is linked or which only works on the instance of a string of a struct. So let's see how to declare a method. So you use the func keyword as usual, and then you use the method name. Let's say custom print2. Okay, so now this is again a normal function. To make this a method function, we need to somehow link this to an instance of a struct. And how do we do that? We basically come here, we add parentheses, and then we use the instance of a particular struct. In this parentheses, we pass in the instance of a particular struct. So let's pass in user, which is basically a pointer to user struct. Or let's say we have not studied pointers now, so let me just remove it. So we can do this. So we are basically passing in the instance of a user object, right? Or let's just call it u for simplicity's sake. So we are passing as parentheses u, which is basically an instance of a user object. So whenever we use this kind of syntax, it means this custom print2 can only be called from the struct instance. It cannot be it cannot be directly called. So this, whenever you declare a function like this, it becomes a method. So this is the syntax of a method, and method is basically a function that is linked to a particular instance of a struct, and it cannot be called without that instance. As simple as that. So this is what methods are. If I again uncomment this, so let me write, this is a function, this is a method. That's it. I think it's not too difficult to understand, I hope. Now this custom print2 will have access to all the internal details of that particular struct. So if I want to print the name, I no longer need to explicitly pass it. I can just directly access it. So I'll say print ln, and then I use u dot name, and then u dot age, and then u dot, if I can properly write it, u dot email, and then u dot password. All right. Okay. And now let's call this. Now let's see how to call methods. So again, we go back to our main function. Now we have an instance of this user struct. So let's just call it user1, and then when you use the dot operator, you will automatically see the custom print function. You can see custom print2 is automatically being shown. Now if I try to run this, yep, you can see it is printing all the details. So what did we learn till now? So basically a function is a normal function which accepts parameters or can be parameterless, and it returns some value or it does some work. But a method is basically a special function which is linked to a particular instance of a struct. So that is the difference between methods and functions. Okay. So I think we are running out of time. In the next video, I will be teaching you about interfaces, which is a little different from structs, but the concept is similar. So next video, we will see how interfaces work, and hopefully we'll try to make some little project next time. I think we have had enough understanding of Golang so far. So in the next video, we can make some project. So yeah, I think that should be enough for now. I hope to see you again for episode 3. And yep, have a nice day. Bye.